Welcome to Gen.Struct.2 and Lateral Forces, Lesson 4 quiz, question number 7. It states that the fundamental period of vibration of a structure is blank. So A, B, C, or D. Let's go down and cross off the ones that are wrong. Fundamental period of a vibration. Well, actually, before we even look at it, let's kind of look at it this way. So if you remember, a period is how long it takes to go from this side, given that the building actually sways that much. It's over exaggerated. Hopefully no building will sway this much. So that's your period. T is usually how you go about it, showing it. And it's the time. It's not, that kind of shows the distance, and that's not right. So I'm just going to leave it right there. Anyways, the period is the time it takes to go one full cycle. If you remember a sine wave, a period is from here to here. So what we want to look there, it's actually 1, 2, it's there and back, in my opinion. And if you think about it, the higher you get, given everything else is equal, the higher that building is, the longer it's going to sway. If you think, I like to think about this kind of like, well, if you take something short and stiff, when you flick it, I guess, it's going to just go, no, and it'll stop very, very, very shortly. I mean, if you have a pencil or something, you won't even see that vibration. It's so short. If you have something very long and slender, it will go back and forth and kind of and then it'll come down. So in the end, the longer this is, the longer this period is, I guess. So as period goes up, as length, let's call it length, L goes up. So this would be L. All right, or as height goes up. So let's look at our answers. Is unrelated. It says the fundamental period of vibration of a structure is unrelated to the height of the structure. That's incorrect. It is related to it. The taller it is, the more it's going to have a longer period. If that makes sense. Decreases. So it's saying that the fundamental period of vibration decreases as the height of the structure increases. It's increase. That's the exact opposite of what we're looking for. All right, the period increases as the height of the structure increases. That is what we're going for. Higher the structure, the more it's going to want to think of a tree, I guess, or a twig. The higher that tree is, the more that tree is going to be able to sway. And the higher it is, the longer it sways back and forth. If you have something really short, it's just going to go doop, 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 doop. All right. And then D may either increase or decrease as the height of the structure increases. And you could try to make a case for this, well, but giving everything else is the same, your best answer is C. Given that your rigidity and your width of this structure is the same, going all the way up, all the rigidities are the same, then your period will increase as the height of the structure increases, which again is C. All right, I will see you on question number 8.